So let's continue our tutorial, and we will after collecting ground control points, the next step is resampling and rectification. So so we already collected ground control points here, and we should now choose the first order polynomial transformation function, and for the resampling techniques we will use both nearest neighbor and bilinear interpolation, and name the first output in raster as slave first n, and second one slave first bl respectively, and save and we'll save it in our workspace with pixel size 2 meters, and the format is grid. So so the first order polynomial is already chosen, and I should just click here to rectify. So pixel size is 2 meters, no data as for instance no data. First one is resampler type, so nearest neighbor. So we can see here there's 3 resampling types: nearest neighbor, bilinear interpolation, cubic convolution. So this one is for discrete data, these two is for continuous data. In our case we have discrete data, but we will use also bilinear interpolation in order to compare the results. So save, and next one is also cell size, no data, and I will choose bilinear interpolation, grid, and slave first bilinear interpolation, right? Bilinear interpolation, and save it. So I just forgot to make a print screen. Anyway, just do not forget to make print screens of your results. What is the meaning of the nearest neighbor and bilinear resampling type options? So I already explained this in a lecture video. So bilinear interpolation uses one pixel, which are spatial overlays with the cell center of input, while bilinear interpolation uses weighted average of 4 pixels. So anyway, just watch the video again, and you can make more research in the internet. So now activating data frame, and we should open those files we just created. So we ended our georeferencing, and now we can open it. So do not forget to save your points if you didn't save them. So here is my data frame 2, and I will open it in my workspace. Here is to my raster images. So this is my raster image. So when you open it, you may see that it doesn't have a legend like here. So in order to compare these two raster datasets with each other, we should import our legend. So for this, open the properties, symbology, and import the Lear file of the slave map right here, right? Slave map Lear. Okay, and here is the legend is imported. So now we have the familiar output. The same is here. Slave map. Okay. So we have here the two images, and the question is which is more correct and why. So it's not hard to understand from the first glance that slave map nearest neighbor is more correct. Why? Because it's for the discrete rasters, and our input is a discrete raster, while bilinear interpolation and cubic convolution is good for the continuous rasters. But anyway, let's compare. So we can see the results here that this slave first and n is more close to our first image, right? Much close to our first image. While when we open the slave bilinear interpolation, we can notice here some strange deviations. So the classes are mixed with each other here on the boundaries of the parcels, while slave bilinear interpolation, it has the same raster values. See, so this here we just mixed nature with boundaries, and also with which one with building. So everyone is mixed actually, but it should be only boundaries. So nearest neighbor of course is more correct because it is for discrete rasters. So next question, add layer master map layer to the data frame 2. So we also have here the master map layer file in our folder. So here is our master map. The link is broken. Anyway, we can repair it with our master map here. So let's activate our data frame. So the question is, what pattern in the displacements between the rectified image and the master map layer can be observed? So let's first compare the nearest neighbor with the master map. So here we can see that the georeferencing was done very accurately. See, some distortions, but mostly they just here some slight distortions here. These places are not very good, but if we will compare these places, these boundaries, we can see that the georeferencing was done pretty accurately. While the same, I think, concerns the bilinear interpolation, but the one disadvantage of bilinear interpolation that the classes on the boundaries are very mixed. Anyway, what patterns displays between the rectified image and the master map can be observed, can be observed. So there is no huge discrepancies between this master map and slave map in my case, but probably you will have some distortions here in these areas. We can see more bigger distortions, but the georeferencing was done pretty accurately. So here I stop the video, and from the next video we will try to use second order polynomial transformation for our georeferencing.